Okay, we started this chapter learning how to use the distributive property with algebraic expressions, and now we're going to end the chapter with doing the opposite, which is called factoring linear expressions. So when we use the distributive property to get rid of parentheses, we were doing what's called expanding an expression, and then now we're going to learn the opposite of that, which is factoring expressions. So to factor something means to write a number as a product of its factors. You're kind of breaking it apart into two things that multiply to give you what you started with. So for example, I could factor the number 10 into 2 times 5. Okay, I broke it into its factors. Or I could factor 24 into 6 times 4. That's called factoring. So when you write something as a product of its factors, that's called factored form. So to do that, we're going to just warm up a little bit here as a reminder of what the greatest common factor of numbers is, in case you forgot. So the GCF is the largest number that will divide the numbers evenly. So the greatest common factor of 4 and 12. What is the largest number that will go into 4 that also goes into 12? Well, the answer to that is 4. So 4 is our greatest common factor of 4 and 12. Next one, what's the greatest common factor of 18 and 24? The largest number that will divide these numbers is 6. And then lastly, the greatest common factor of 45 and 60. The largest number that divides 45 and 60 is 15. Okay, so that's just a real quick reminder of greatest common factor. Now we want to find greatest common factors of monomials, okay? Factors of terms that might contain variables. What is the greatest common factor of these monomials? Well, 4x means 4 times x, and 12x means 12 times x. So they both have x as a factor. They're both being multiplied by x. So to find the greatest common factor of a monomial is pretty easy. It's just like finding the greatest common factor of numbers, but if they share the same variable, that means that that variable is also a factor as well. So that's going to get included in our GCF. So what's the greatest common factor of 4x and 12x? Well, the greatest common factor of 4 and 12 we saw on the last slide was 4. And they both contain an x. They're both being multiplied by x, so they both have x as a factor as well. So the greatest common factor of 4x and 12x is 4x. Next one, the greatest common factor of 18a and 20ab. Well, again, the greatest common factor of 18 and 20 is 2. And then if we're looking at the variables, they both have an a. They're both being multiplied by a, so a is a common factor, but the first monomial is not being multiplied by b. It does not have b as a factor, so it's not going to be in the greatest common factor. So the greatest common factor of these two monomials is 2a. So there's just a quick overview of finding greatest common factors. Let's try a few more just to see if we can get the hang of this. If you'd like to pause the video and see if you can get these on your own first, that would be great. But I'm going to do these right now. The greatest common factor of 12 and 28c. Well, the greatest common factor of 12 and 28 is 4. And 12 does not have a factor of c, so I'm not going to put a c in there. So the greatest common factor of these monomials is 4. Next one, 25x and 15xy. Greatest common factor of 25 and 15 is 5. And they both have an x in them, so that is a common factor as well. So the greatest common factor is 5x. And then the last one, 42mn and 14mn. The greatest common factor of the coefficients is 14. 14 goes into both. And then they both have an m and they both have an n, so they are included in the GCF as well. So their greatest common factor is 14mn. So now that we know how to find greatest common factors, we can use that to factor a linear expression. So how do you do that? You're going to find the greatest common factor of every term in the expression, and this is what's going to end up going outside the parentheses. So kind of think of the reverse distributive property. Now we're going to introduce parentheses, whereas with the distributive property, we got rid of them. So we're going to kind of pull out that greatest common factor and then figure out what goes inside the parentheses. And to do that, that's step 2. We're going to divide every term by the GCF. These go inside the parentheses. So let's factor 3x plus 9. So basically, the train of thought here is, what did this look like before the distributive property? Well, the first step is find the greatest common factor. The greatest common factor of 3x and 9 is 3. That means both of these terms could have been multiplied by 3. So I'm going to put that outside the parentheses. 3 times what now would give me 3x plus 9? Well, 3 times what would give me 3x? 3 times x is 3x plus, since there's a plus sign here, 3 times what would have given me the 9? Well, 9 divided by 3 is 3. So here is that expression in factored form. So basically we undid or reversed the distributive property. So now we get 3 times x plus 3 as our factored form. Now a great way to know if you factored something correctly is to just use the distributive property to check. So if I do the distributive property and multiply everything in the parentheses times 3, I get, voila, 3x plus 9, which is what I started with. So these are equivalent expressions. Now I have just factored it. I've kind of reversed the distributive property there. So let's take a look again at some examples. Let's try to factor each expression if possible. Not every expression is factorable. If they don't have a common factor, then we can't factor it. So again, 4x and 28, what's the greatest common factor of these terms? And that would be 4. So now I need to determine what goes inside the parentheses. 4 times what gives me 4x? That would be x, plus 4 times what is 28? That's 7. And again, if I'm not sure, I'm just going to do the distributive property here. 4 times x is 4x, and 4 times 7 is 28. That checks out. I've done it correctly. Next one, 3 plus 33x. The greatest common factor of 3 and 33x is 3. And then what goes in the parentheses? Well, 3 times what is 3? That'd be 1, plus 3 times what is 33x? 11x, and I'm done. That's factored form. Again, I'm going to double check to make sure. 3 times 1 is 3, plus 33x. That checks out. I did it correctly. Always remember to divide everything by that greatest common factor. A lot of students will only do the first term and then they'll get it wrong. Next one, 4x plus 35. Greatest common factor of 4x and 35 is 1. So I'm not going to factor a 1 out. These do not have a greatest common factor. These are what we call relatively prime numbers, so that we're just going to write cannot factor when that's the case. Sad. Okay, so if you have an expression that can't be factored, don't force it. Just write cannot be factored. So here, write an expression for the total area in factored form. So we've got 2 rectangles combined together to form one larger rectangle, and we're going to express the entire area in factored form. Well, the entire area would be if I added these two together. So that would be 5x plus 20 is the entire area. But now we want to factor that. So if we find the greatest common factor of 5x and 20, that would be 5. And 5 times x is the 5x, and 5 times 4 is the 20. So here is the area in factored form. So that basically tells me that this rectangle is a 5 by x rectangle. That gives me the 5x for the area. And this rectangle over here is a 5 by 4 rectangle, which gives me the 20 for the area there. So I can find the dimensions of this rectangle now if I think of factoring that expression. Write an expression in factored form that is equivalent to the given expression. So now when we've got fractions involved, it's kind of hard because we don't normally think of greatest common factors with fractions involved, but we can kind of expand our understanding of factoring to include things that are non-whole numbers. So really what we want to do is just put something outside the parentheses that is a factor of some sort of 1/2 x and 4. Well, the easiest one I could think of here is 1/2. If I factor out a 1/2, 1/2 times x is 1/2 x, and 1/2 times what is 4? That would be 8. So I can factor this expression if there is something that will multiply by each term to give me what I started with. So 1/2 times x plus 8 is a way to factor this expression. There's actually more ways to factor this expression, like if I divide everything by 2. Okay, 2 times what is 1/2 x? 2 times 1/4 x is 1/2 x, and 2 times what is 4? 2 times 2 is 4. This is also an equivalent expression. So all three of these on the screen now are equivalent expressions, because if I do the distributive property again, 2 times 1/4 is 2/4 or 1/2, and 2 times 2 is 4. So that's another way you can factor it. How many other ways can you think of to factor this expression? What about dividing everything by 4? 4 times what is 1/2 x? That would be 1/8 x. And 4 times what is 4? That'd be 1. So there's another way I could factor that. 4 times 1/8 x plus 1. I could also factor out or divide everything by 1/4. 1/4 times what is 1/2? 1/4 times 2. So 1/4 times 2x is 1/2 x, and 1/4 times what is 4? 1/4 times 16 is 4. So there's yet another way I could factor that. And we could go on and on here with lots of different numbers and fractions outside the parentheses to factor this. So there are lots of ways that you can factor some expressions. So keep that in mind and get creative when you're doing that.